In Young's double slit experiment, the fringe width is 5 into 10 power minus 4 meter. If the distance between the slit and screen is doubled and the distance between the two slits is reduced to 1/4 and wavelength is changed from 3.2 into 10 power minus 7 meters to 8 into 10 power minus 7 meters, the value of new fringe width will be, we know that beta is equal to lambda into capital D by small d, or that implies beta 2 divided by beta 1 is equal to lambda 2 divided by lambda 1 into capital D2 by D1 into small d1 divided by d2, or that implies beta 2 is equal to beta 1 value is given 5 into 10 power minus 4 into lambda 2 value 8 into 10 power minus 7, lambda 1 3.2 into 10 power minus 7. So, here 10 power minus 7 cancelled and into d2 is given double of d1, so that we can write it as 2, and d2 small d2 is given d1 by 4. So, d1 by d1 by 4, that is, or that implies beta 2 is equal to 5 into 10 power minus 4 into 32 into 2 divided by 32 into 10 power minus 1. 32 cancel. So, 5 2s are 10 into 10 power minus 3, or that is equal to 1 into 10 power minus 2 meter. That is, option D is the right option. And next question. In a single slit diffraction experiment, the width of the slit is reduced by half. Which of the following needs to be done if the width of the central maximum has to remain the same? Width of the central maximum is equal to 2 lambda capital D by small d. When small d is reduced to half, let us assume that W dash is equal to 2 lambda capital D by D by 2, or this can be written 2 into 2 lambda capital D by small d. To have W is equal to W dash, here this 2 extra is there in W dash. To cancel this 2, we have two possibilities. Either lambda becomes lambda by 2, or second possibility is capital D should become D by 2. Any one of these two is the right option. So, as per the given options, option A, that is reduce the distance between the slit and screen by half, so that second possibility is the right option. Next question. Which of the following is the best method to obtain coherent sources? By using two coherent sources or two slits is the right answer. Next question. A point P is situated 90.50 centimeters and 90.58 centimeters away from two coherent sources. The nature of illumination of the point P if the wavelength of light is 4000 angstroms. Here path difference delta x is equal to n lambda, that is equal to 90.58 minus 90.50, that is equal to 0.08 centimeters or 8 into 10 power minus 4 meters, or that implies n is equal to 8 into 10 power minus 4 divided by lambda. Lambda value is given 4000 angstroms or 4 into 10 power minus 2 meters, minus 7 meters. So, that is 2 into 10 cube or 2000. So, it is a even number 2000. So, that P becomes a bright band. Next question. Colors in thin films are due to interference phenomena. It is interference of light. Next question. A stone thrown into still water creates a circular wave pattern moving radially outwards. If small r is the distance measured from the center of the pattern, the amplitude of the wave varies. We know that intensity is always inversely proportional to distance and intensity is directly proportional to amplitude square. So, therefore, A square is directly proportional to 1 by r. Taking square root on both sides, you can write it as A is directly proportional to 1 by r to the power of 1 by 2 or A is directly proportional to r to the power of minus 1 by 2. So, option A is the right option. Next question. A light wave travels through a medium carrying energy in three-dimensional space. Energy spread is described by. So, three-dimensional space, light travels in three-dimensional space in the form of wave front. So, option C is the right option. Next question. In Young's double slit experiment, the fringe's width is found to be 0.4 millimeters. If the whole apparatus is immersed in water of refractive index 4 by 3 without disturbing the geometrical arrangement, the new fringe width will be. So, fringe width inside the liquid is equal to fringe width in air divided by refractive index of the liquid. So, that implies beta in liquid is equal to beta in air is given 0.4 millimeters and that is equal to 4 by 3 refractive index of liquid is given 4 divided by 3. So, that is 4 0.1. So, that is 0.1 millimeters into 3. So, that implies fringe width in liquid is equal to 0.3 millimeters. 0.3 millimeters, that is option A is the right option. And next question. In YDSE, if the screen is moved away from the plane of the slits, the fringe width of interference fringes will. We know that fringe width beta is equal to lambda into capital D by small d, or that implies beta is directly proportional to capital D. If capital D increases, then beta also increases. So, that option A is the right option. Next question. Which of the following can exhibit diffraction phenomena? Photons, electrons, neutrons. So, option D, all of these is the right answer. Photons are electromagnetic radiations. All electromagnetic radiations exhibit diffraction, and electrons, neutrons are the material particles. According to de Broglie hypothesis, electrons and neutrons are also associated with the waves, so that all the three, photons, electrons, neutrons, exhibit diffraction. So, that option D is the right option. Next question. A slit of width small a is illuminated by white light. The first diffraction minimum for light of lambda is equal to 6500 angstroms is formed at theta is equal to 30 degrees. Then the width A of the slit is. So, in case of single slit experiment, path difference A sin theta is equal to n lambda for minimas, but for first minima n is equal to 1. For first minima n is equal to 1. Therefore, A sin theta is equal to lambda, or that implies A is equal to lambda divided by sin theta, or that is lambda is given 6500 angstroms. 1 angstrom is equal to 10 power minus 10 meters, and sin 30 degrees, sin 30 is equal to 1 by 2. So, that implies A is equal to 2 into 6500 into 10 power minus 10, or that is 13,000 into 10 power minus 10, or this can be written as 1.3 into 10 power minus 6 meters. That is option C is the right option. Next question. The headlights of a jeep are 1.2 meters apart. If the pupil of the eye of an observer has a diameter of 2 millimeters and light of wavelength 5896 angstroms is used, what should be the maximum distance of the jeep from the observer if the two headlights are just separated? Let us assume that observer is standing at a particular distance, say x from the headlamps of the jeep. This position O is the observer position, and A comma B are assumed as the headlamps of the jeep. So distance between these headlamps is given 1.2 meters. Let us assume here angle is theta. In the diagram, tan theta is equal to d divided by x. For small angles, so theta, tan theta is equal to theta, or therefore theta is equal to d divided by x. But limit of resolution for human eye, theta is equal to 1.22 lambda divided by capital D, where capital D is the diameter of the pupil of the human eye. So by equating these two, we can get small d divided by x is equal to 1.22 lambda divided by d, or by cross multiplication we can get x is equal to small d into capital D divided by 1.22 lambda, or that implies x is equal to small d is given 1.2, capital D is given 2 millimeters, so 2 into 10 power minus 3 divided by 1.22 into lambda is given 5896 angstroms. 1 angstrom is equal to 10 power minus 10 meters. Approximately 1.2, 1.22 cancel. So that is equal to 2 into 10 to the power of 7 divided by 5896, or that implies x is equal to say 20,000 into 10 cube divided by 5896. So it is approximately 3336 meters, or x is equal to 3.336 kilometers. So the nearest option is C is the right option. Next question. What is Brewster's angle for air glass transition? We know that Brewster's angle or tan theta p is equal to mu at Brewster's angle or at angle of polarization, or theta p is equal to tan inverse of mu, or that is equal to tan inverse of 1.5. So we know that here we are following elimination method. Tan 45 is equal to 1 and tan 60 degrees is equal to 1.732, that is root 3. Now our answer is 1.5, our value. 1.5 is very close to 1.7. So that theta p is very close to 60 degrees as per the given option. So we can take it as 56 degrees 18 minutes, elimination method. And next question. A beam of light is incident at polarizing angle theta on air glass interface. If lambda A and lambda G are the wavelength of light in air and glass respectively, then we know that mu is equal to tan theta, Brewster's law, and mu can be written as wavelength of light in air medium divided by wavelength of light in glass medium as per the question is equal to tan theta, or that implies lambda g is equal to lambda a divided by tan theta, or that is lambda a into cot theta. So, lambda g is equal to lambda a into cot theta, that is option B is the right option. Next question. In Young's double slit experiment, the intensity of light at a point on the screen where the path difference lambda is k units. What is the intensity of the light at a point where the path difference is lambda by 3 and lambda being the wavelength of light used? We know that path difference is directly proportional to intensity, or intensity is directly proportional to path difference, or that implies I is equal to C into delta x, where C is a proportionality constant. So, C into, if path difference is lambda, I is given as k, that implies k is equal to C lambda, or C is equal to k divided by lambda. If path difference delta x is equal to lambda by 3, then I dash is equal to C into lambda by 3, but C is equal to k by lambda into lambda by 3. So, lambda lambda cancel, that is k divided by 3 is the intensity at path difference lambda by 3. Next question. The phenomenon of polarization shows that light has dash nature, transverse nature is the answer. Next question. Two light waves are given by E1 is equal to 2 sin 100 pi into t minus kx plus 30 degrees and E2 is equal to 3 cos 200 pi minus k dash x plus 60 degrees. What is the ratio of intensity of first wave to that of second wave is? Here we know that intensity is directly proportional to amplitude square, or I1 divided by I2 is equal to A1 divided by A2 whole square. That is, amplitude in the first wave is given 2, amplitude of the second wave is given 3. So, that is equal to 2 by 3 whole square, 4 divided by 9. That is option B is the right option. Next question. An unpolarized beam of light is incident on a plane surface separating air and glass at an angle equal to the Brewster's angle. Then option A is the right option. The reflected light has electric component only perpendicular to the incident plane. Next question. Two monochromatic light waves of amplitudes 3a and 2a interfering at a point have a phase difference of 60 degrees. The intensity at that point will be proportional to, we know that resultant amplitude is equal to square root of a1 square plus a2 square plus 2a1 a2 cos phi. So, that is equal to square root of a1 is given 3a, so 3a whole square plus a2 is given 2a, so that 2a square plus 2 into 3a into 2a into cos 60, phi is given 60 degrees. Cos 60 degrees is equal to 1 by 2. So, cos 60 and 2 cancel, that implies square root of 9a square plus 4a square plus 6a square, that is equal to square root of 19a square. But we know that intensity is directly proportional to amplitude square. So that implies I is directly proportional to 19A is the 19A square is the answer. So that option D is the right option. Next question. The path difference between two identical waves arriving at a point is 100.5 lambda. If the path difference is 44 micrometers, then wavelength of light will be. So path difference delta x is given 100.5 lambda. Path difference is also given 44 into 10 power minus 6 is equal to 100.5 into lambda, or lambda is equal to 44 into 10 power minus 6 by 100.5, that is equal to, suppose if denominator has only 100, 0.44, but little bit higher value is there, 0.5 higher, so little lesser than 0.44 is the answer, or in terms of angstroms we can write it as 4378 angstroms is the answer. That is option A is the right option.